Welcome all. In the last class, we discussed about architecting the neural network, how to develop an artificial neural network, and what are the advantages and disadvantages of using artificial neural network. In today's class, we are going to see another important data mining technique, that is cluster analysis. Cluster analysis is one of the uh, data mining technique which falls under the category of unsupervised learning. Cluster analysis is an exploratory data analysis tool used for organizing observed data or cases into two or more groups. Cluster analysis aims at the detection of natural partitioning of objects. In other words, it groups observations that are similar into homogeneous subsets. So, in today's class, we are going to see introduction to cluster analysis, applications of cluster analysis, then definition of a cluster, then representation of clusters, and then a general clustering technique. So what is a cluster analysis? So it is used for automatic identification of natural grouping of things. So cluster analysis is used for grouping of the objects. It is also known as segmentation technique because it properly segments the different objects based on their similarities. In this technique, data instances that are similar to each other are categorized into one cluster, and data instances that are very different from each other are moved into different clusters. So in the cluster analysis, so the data points that are having a similar feature, so they are categorized in one cluster, and data instances that are having a different similarities, so they are placed into the different clusters. So clustering is an unsupervised learning technique, as there is no output or dependent variable for which a right or wrong answer can be computed. So we know that in unsupervised learning we are not knowing the result in advance. Okay, so that is, there is no dependent variable. The correct number of clusters for the definition of those cluster is not known ahead of time. So that is why it is an unsupervised learning. In advance, we cannot predict how many clusters can be devised for a given data set. Clustering techniques can only suggest to the user how many cluster would make sense from the characteristics of the data. So the user can specify different larger or smaller number of desired clusters based on their making business sense. So that is the clustering technique. So it will give the optimum number of clusters, so that give proper sense for the based on the data. It depends upon the user who can specify a larger or smaller number of cluster based on their business need. The cluster analysis technique will then define many distinct clusters from analysis of the data with cluster definition for each of those clusters. Then where all the clusters are used? So clustering analysis is used in almost every field where there is a large variety of transactions. Suppose if I want to know the genuine transaction and fake transaction, so based on some financial data, so transaction data, I can properly cluster which data are having a particular transactions and which are having some of the fake transactions. And then we can use a cluster to group the peoples who are having a same buying pattern, who are having a very high demand for some products. So based on this, we can serve the customer according to the premium. So it helps to provide characterization, definition and labels for population. So it can help identify natural groupings of customers, products, patients and so on. So the grouping can be of a group of customers or group of products or patients and so on. It also helps to identify outliers in specific domain and thus decrease the size and complexity of the problem. So the first thing is the market segmentation. So how the cluster analysis can be used in market segmentation is we can categorize customers according to their similarities and uh, for example their common wants, needs and propensity to pay can help with the target marketing. So based on the customer buying pattern, so we can decide what type of uh, values the customer is having. So based on his buying pattern, so we can give some premium services to the customers of the higher demands. Then product portfolio. So people of similar sizes can be grouped together to make small, medium and large sizes for clothing item. So for example, suppose I want to make a t-shirt for a group of 60 people. So then I cannot give 60 different sizes of the t-shirt. So hence what I will do is, so I will make the persons of the height above 5.5 as 1 category and below 5.5 to that is above 5 and below 5.5. So I can make one cluster, one group, and the person from 4.8 to 5, so I can group them. And based on the so based on this criteria, so I can make 3 clusters and I can give the sizes of the t-shirt. So that's how the similar sizes can be grouped to make small, medium and large for clothing items. Then text mining. So clustering is also used in text mining, which can help organize a given collection of text documents according to their content similarities. So based on the content of the text, so we can group this news belongs to sports category, this text belong to education category. So in that way we can group the text data. So then next is the definition of a cluster. What is actually the clustering definition in technical terms? The operational definition of a cluster is, given there are n objects, we need to find k groups based on a measure of similarity, such that objects within the same group are alike but the objects in different groups are not alike. Okay. So what it means is, we have n objects. So for example, if you consider this diagram, so if there are n objects, so I need to find k groups. If they assume if there are 20 objects, then I need to make some 2 or 3 groups based on the need. So how I make the group is based on a measure of similarity. So we can use different measures of similarity such that, so how the similarities work is, so the data points in the group are having this less distance and the greater data points between the two clusters are having a large distance. Okay, so such type of measure can be used for the making the clusters. An ideal cluster can be defined as a set of points that is compact and isolated. In reality, cluster is a subjective entity whose significance and interpretation entirely needs the domain knowledge. So based on the based on the need, we need to specify the clustering. So hence the domain knowledge about the particular subject is needed. Now, if you look at in the above figure, there are 3 clusters approximately equal size. Okay. However, they can be seen as 2 clusters depending on how we draw dividing line. There is not truly optimal way to calculate it, so we can use heuristic to define number of clusters. So if I draw a line between these two clusters and this, so then what I can say is this can form one cluster and this can form another cluster. So in that way I can form the two clusters. But since this is an unsupervised learning technique, so we cannot perfectly say that these many number of clusters has to be made for this much of data objects. Okay, so that's what the unsupervised learning is. Okay, we can most of the time use the heuristic techniques to define the number of clusters. Then how to represent the clusters? Clusters are represented by the the measures of central tendency parameters. For example, mean, median, mode, or dispersion. So they can be used as the representation for the cluster. So here the clusters are represented by a central or a modal value. So modal value is nothing but mode. A cluster can be defined as centroid of the collection of points belonging to it. A centroid is a measure of central tendency. It is the point from where sum total of square distance from all the points is minimum. So in some of the cases we use centroid as a measure of central tendency, so which mean that the total square distance from all the points is minimum. Okay, so that is one of the central measure of central tendency. Okay, so we can also use model, that is mode. A cluster can also be represented by the most frequently occurring value in the cluster. We know that in statistics most frequently occurring value is called the mode. That is, the cluster can be defined by its modal value. Cluster analysis is a machine learning technique. The quality of a cluster depends on the algorithm, distance function, and the application. So we know that the machine learning technique, so the ultimately the cluster analysis is a machine learning technique. So it depends on the algorithms, machine learning algorithms that are being applied. Yeah. Then the first thing is the distance. So the distance function is one of the important component in cluster analysis. So depending on the distance function, we can decide how many clusters we can form, and choosing of a distance function depends on the data set, depending entirely on the behavior of the data set. So most cluster analysis methods use distance measure to calculate the closeness between pairs of items. So most of the cluster analysis methods use this distance measure to find the similarities between the pair of items. So the two measures of distances, there are many distance measures. The first is Euclidean, Manhattan, Mahalanobis, and then we have Minkowski distance, Chebyshev distance. So there are many different distance functions exist. So but we are using commonly Euclidean distance, which is similar to the Pythagoras theorem. It is nothing but the hypotenuse of a right angle triangle. Okay. So Euclidean distance is the most commonly used distance measure. Then we can also use Manhattan or city block distance, which indicates that when the data is in when the data has high dimension, then in such cases we use the Manhattan or city block distance. But for low dimensional data, Euclidean distance is the more suitable. So if the data contains correlations or a kind of covariance or variance between different elements of the data, then in that case Euclidean distance will not work. So in such cases we go for Mahalanobis distance. Okay. So but most commonly we are using the Euclidean distance. Okay. So in either case, whether we use any distance measure, so the main goal remains same. The intercluster distance is maximum and intracluster distance is minimum. Means the elements which are there in this cluster, the distance between them must be minimum as compared to distance between the different objects in the different clusters. Okay. This distance should be maximum, whereas this distance should be minimum. So that is the entire goal of using any of the distance functions. Then coming to algorithm, there are many algorithms to produce cluster. So there are so the one which we study in this chapter is also one of the most famous algorithm, that is k-means clustering algorithm. But all clustering algorithms follow a general approach. Okay. So that is there are top down hierarchical methods that start with creating given number of best fitting clusters. There are also bottom up methods that begin with naturally occurring clusters. So cluster algorithms, in some cases, first we start with a fixed number of clusters and then we go on fitting the data points into these fixed number of clusters. And there are some bottom up clustering algorithms, so where we find the natural grouping among themselves and we go on building the clusters. So what is the general approach for the clustering is, we pick an arbitrary number of groups or segments to be created. Okay. First we guess how many clusters can be performed, clusters are to be created for the given data. Next we start with some initial random guess, that is chosen central values for groups. Next we select the central value for a given number of clusters, random central values. Okay. Then we classify instances to the closest group, that is we based on these central values we see which of the data points are close to the central values. Then we just map all the data points to the nearest central values. Then we compute new values for the centers. Next we repeat the step 3 and 4 till groups converge. So we repeat the steps 3 and 4 indicates that we are performing classifying instances into groups and mapping them to corresponding central values. So until the groups converge means until after so many iterations the central values are not changing their numbers, that is their values. Okay. In such cases we can say that the clusters are converged, that the central values are converged, then we can say at that time we can stop the iteration. Okay. If clusters are not satisfactory, then go to step 1 and pick a different number of groups or segments. If we are not satisfied with the grouping, then we can go and change the arbitrary number of clusters what we have chosen, then we can again go on with the steps. Now if we choose so many clusters, then the possibility is that we need to have a more computation. If we choose less number of clusters, then possibility that most of the data may fit into only few clusters. So either of them is a bad technique. So the thing is that depending on the data set and depending on the need of grouping, so we have to decide how many clusters we need to perform. So that is the common approach for the clustering algorithms. Okay. So almost all clustering algorithms, they follow this common procedure. Okay. So this is the thing what is see, suppose if you see here, So initially if we decide we want 3 clusters, then based on these central values, so we can assign the clusters, we can assign the data points to the nearest cluster, and once these data points, that is central values, they converge, then we can at that time we need to stop the clustering. Okay, so that's thing. Let's summarize what we discussed. So cluster analysis is a useful unsupervised learning technique that is used in many business situations to segment the data into meaningful small groups. So cluster analysis, first thing, it is an unsupervised learning, and then it is used in many business situations to segment the data, because if I have a huge data, then I cannot group which type of customers have which type of demands. So it may be very difficult to serve for their expectation. So in such cases we will use cluster analysis to group the customers. So that is a very helpful technique in case of the business situation. That is in a business, in many business situation, it segments the data into meaningful small groups. Okay, so that's for the today's class. Thank you.